Hello, in this video we're going to take a look at how we can use the payout annuity formula from a previous section and repurpose it to compute loan payments. So if you recall from a previous section, we have these two formulas, which are really just the same formula but rearranged. On the left, we have a formula that says, if I want to withdraw W dollars each period, usually each month, how much would need to be in the account, the principal P. So the principal P can be computed if I know how much I'm going to pull out every month and all the other information about that annuity. We also talked about how you can flip that around, so to speak, and say if I have P dollars in the account and I know all the other information about the rate of return and how many times I'm going to take out money each year, then what will the regular withdrawal be? So these are really just the same equation but rearranged. Now, we can think about the withdrawal W as a loan payment. So in other words, we're withdrawing money from our account to make some payment. So the same exact equation can be used to compute loan payments. What we do is we say let P be the initial amount borrowed, and let PMT be the regular payment on that loan. So really what you have here is W, the withdrawal, is being replaced with PMT, the payment. So if you go back and look at the equations, you have essentially the same equation now with new variables. Instead of W, you have PMT for the payment over here on this side, and then when you rearrange it, you end up with the same thing here. So what we have here on the left is an equation that answers this question. If I can afford a payment of PMT dollars, so I know this amount here on the right side of the equation, how much total money can I borrow? What's the principal P that I can borrow if I can afford this amount of payment? So if you know you have, let's say, $300 that you can spend on a car payment, then you could then determine how much you could borrow, P. And then the other piece on the right side here, the other equation, if we rearrange the one on the left, we get this one on the right, which answers a related but similar question. If I borrow a total of P dollars, what will my payment be each period, typically each month? So we have a really flexible formula that applies not only to payout annuities, but also to loans. So let's take a look at an example. Let's say a couple is going to put a 20% down payment on a $650,000 home, and they're going to borrow the rest with a loan that has a 4.5% annual rate of interest, and it compounds monthly, so K is 12. They're going to use a 30-year mortgage, which is pretty standard, and they want to know what is the monthly payment going to be. So there's our situation. Let's look at the formula that we're going to be using. The P is the amount we're going to borrow. We know the rate of return, it's 4.5%. We know K is 12. We know T is 30 years. So we can compute the payment that the couple is going to have to make each month. So we first start by saying how much are we going to actually borrow. We're not borrowing the full $650,000 because we have a 20% down payment that we're making. So if I start with the $650,000 sale price and then I subtract 20% of that sale price, I get the total amount that I'm borrowing from the bank. It's $520,000. So that's P, the principal for the loan. So now we can fill in our variables. As I said, P is $520,000. The rate of interest is 0.045, 4.5%. We have 12 payments per month, and interest on the loan is compounded monthly. And we're going to pay it off for a total of T equals 30 years. When we put all those numbers into that equation, we get the following. Plugging numbers in, the principal, capital P, is $520,000. The rate of return is 0.045. That appears here in the numerator and also here in the denominator. The value of K is the number of payments per year, which is 12 monthly payments. So K shows up down here in front of the parentheses, and then down here inside the inner parentheses, and also up here as part of the power, which is negative. And then T shows up once for 30 years. When I do this calculation, I get a payment of $2,634.76. And this is just, again, showing how we could do this in Desmos. Desmos is, again, a great calculator that allows you to visually lay out your calculation very clearly so that it matches what you expect it to. And you can see that's the result that I get here. So to answer the question, which was how much is their payment going to be, it's going to be $2,634.76. So that's an example of how we can use the annuity payout formula, repurpose it into a payment formula on loans with a principal P.